Alright, this video looks at rotation symmetry. So far we've looked at line symmetry, and today we're going to look at rotation symmetry. So we mentioned in our very first video what rotation is, but we'll look in more detail in this video. So remember that rotation symmetry occurs when a shape or design can be turned about its center of rotation so that it fits onto its outline more than once in a complete turn. So an example might be a shape like a square. If we take the center of the square and we started rotating it around, if we rotated it a quarter of a turn, we would end up with a square again that would fit exactly right over top of the original. So if you hadn't seen the rotation, you wouldn't even know that the rotation had happened. It would look exactly like the original. That means that a square has rotation symmetry. So a couple definitions. The center of rotation is the point about which the rotation of an object or design turns. So we'll do the example of the square again. If we're rotating around the center, and that point right there would be our center of rotation. Very simple. Okay. The order of rotation is the number of times a shape or design fits onto itself in one complete turn. So we'll use the square one more time as an example. Okay, I mentioned before, if we rotated it a quarter of the turn, it would look the same as the original, but it would also look the same if we rotated it halfway around, another quarter, and another quarter, and then of course all the way around. So altogether there would be 4 different times, if you stopped it 4 different times, a quarter of the way around each time, and you would not be able to tell that it had been anything different from the original. So that means that the order of rotation of this square would be 4, okay? Because there are 4 different times along the way that it would look exactly like its original, that it would fit onto itself. Okay, so order of rotation would be 4 for a square. The angle of rotation is the minimum measure of the angle needed to turn a shape or design onto itself. So you'll have to remember a couple things here. If we turn all the way around a circle, that angle measure is 360 degrees. Okay, that doesn't look like 360 at all. Write that more clearly. Change color to 360 degrees is all the way around. Okay, so if we back to, actually we'll do a new shape here. We'll do a triangle. Okay, an equilateral triangle. Okay, our center of rotation here. Okay, so assume that this is an equilateral triangle. If we rotated it around, we would see that there would be 3 different ways that we could get back to the original, meaning the order of rotation would be 3. Okay. The angle is then the minimum measure of the angle needed to return a shape. So the minimum would be once along this path, okay? Or basically a third of the entire circle around. So if we took a third of 360 degrees, that's 360 divided by 3, that's 120 degrees. So the angle of rotation for this triangle would be 120 degrees. Okay, I hope that is clear. We're going to give you a chance to work on both of those, finding the order and the angle of the rotation. So I'm going to draw out 3 shapes, and we'll do the first one together, and then the second 2 I will check in your notes tomorrow to make sure that you have been able to get those ones as well. So I'll draw these shapes out, and then we'll start the video again. Alright, so for the first one, letter A, we have a pentagon. We'll call it a regular pentagon, meaning all the sides and the angles are the same. So the drawing doesn't quite look like that. Assume it's a regular pentagon. We are going to determine what the order is and the angle of rotation. So the order first is how many times, if we rotated it around, would it appear the exact same? Would it fit over itself? And so we can simply draw our little arrows. If we rotated it that far, that far, that far, and that far, 1, 2, 3, 4, 5 different times we could rotate it, meaning the order of pentagon, the order of rotation of a pentagon is 5. The angle, therefore, is the minimum amount, so one of these angles, and the way that we could find that would be 360 degrees, that's all the way around, divided by 5, because we're splitting it into 5 smaller angles, and if we do the math on that, that works out to 72 degrees. Okay, so the order of a regular pentagon, order of rotation is 5, and the angle is 72 degrees. Okay, so there are 2 more examples here I'd like you to take a look at on your own. See if you can solve them, and we'll check that in your notes then tomorrow. Okay, that is all for this lesson. Hope that was helpful. Thanks.